Good morning to all of you. We are discussing the finite automata, that is non-deterministic finite automata, NFA. Second type of automata. The first type of the finite automata is nothing but deterministic finite automata, that is nothing but DFA. Right. So in the previous lecture, we have discussed about the NFA with epsilon moves. Right. So what is the importance of NFA with epsilon moves, and what exactly is the epsilon moves? Epsilon moves means what? In case of non-deterministic finite automata or in NFA, if you want to change the state, from the current state to the next state, yes, it is possible, and this is possible with the help of epsilon moves. Epsilon moves means no input is required here in case of epsilon moves. Still, without any input, the automata is able to change the current state to the next state. So we are referring it as a epsilon moves or the epsilon transitions, right? So what we have to do here, see the figure given on the screen. So NFA with epsilon moves, right? So NFA with epsilon moves, we have to convert that NFA with epsilon moves to NFA without epsilon moves. And finally, this NFA without epsilon moves need to be converted into the DFA, that is nothing but our deterministic finite automata, right? So NFA with epsilon moves can be converted to NFA without epsilon moves, right? And this is possible with the help of some method. So see here, this diagram or this figure is very important, because here onwards we have to see this three conversions, right? So first we are going to convert this NFA with epsilon moves to NFA without epsilon moves, and then the conversion of NFA without epsilon moves to DFA, and finally conversion of NFA with epsilon moves to DFA. Right. So already we have seen the significance of NFA, drawing NFA. The NFA, as per the flexibility, NFA is more flexible as compared to your DFA, right? And it is very easier to draw the NFA as compared to DFA. So for any given problem, for any given language, you can easily draw its NFA with epsilon moves or without epsilon moves. And later on, you need to convert that NFA with or without epsilon moves to the DFA. So what exactly is the process that we are going to see? So remember these 3 points: the conversion of NFA with epsilon moves to NFA without epsilon moves, right? Then this is the first one. The second one, conversion of NFA without epsilon moves to DFA. So once you convert this NFA without epsilon moves to NFA, with epsilon moves to NFA without epsilon moves, then it is easy to convert that NFA without epsilon moves to DFA. This is first part. The second part is conversion of NFA with epsilon moves to DFA. Directly, how to convert this NFA with epsilon moves to DFA? Means our ultimate goal or our final goal is to obtain the DFA, or to draw a deterministic finite automata for a given language or for a given problem. Then how to draw it? The very first step, you can have NFA with epsilon moves with you. You can draw it with the help of this epsilon moves or the epsilon transition, which is very simple one. Then you can convert this with epsilon moves to without epsilon moves, another point. And finally, you need to convert this into the deterministic finite automata. So how? So we'll see one by one. So first we discuss this particular point. We'll see some examples on this first conversion with epsilon moves to without epsilon moves. Then in the next, we're going to solve the NFA without epsilon moves to DFA directly, and finally we are also going to see how to convert the NFA with epsilon moves to DFA. There are examples. We are going to see examples on each of these topics, right? So let us start. Conversion of NFA with epsilon moves to NFA without epsilon moves. That is the first point. See here. Very important point. Conversion of NFA with epsilon. Conversion of NFA with epsilon to NFA without epsilon means we can say that epsilon NFA, it can be converted into the simple NFA or NFA without epsilon moves. This epsilon NFA, ENFA, can be converted into the NFA. So NFA with epsilon moves can be converted to equivalent NFA without epsilon moves. The NFA with epsilon moves, how to define? So you know the You know very well what is the definition of NFA with epsilon moves. So Q sigma delta Q0 F, where Q is nothing but it is finite number of states. Sigma is nothing but it is a set of finite input alphabet. Delta is nothing but your transition function. Q0 is nothing but the start state, and F is nothing but your final state. Right. So, and the delta function or the transition function, I can say here. So transition function in case of NFA with epsilon moves, it is defined like this: Q into sigma union epsilon gives you 2 raised to Q. It is NFA. Ultimately, it is NFA. So NFA means what? You are getting here states in the power of 2. States must be in the power of 2 factor, right? But what is the difference here? Input alphabet multiplied by number of epsilon transition, or multiplied or union by epsilon transition. So what you are do here, Q into inputs plus union means plus, you have to take this epsilon transition into consideration, which gives you the next state, so current state, you know the significance, how to read the transition function. Current state into input alphabet having along with the epsilon transitions or the epsilon state gives you the new state or the next state. In case of your ENFA, this is the definition of our ENFA. Now this ENFA you have to convert into a simple NFA or NFA without epsilon moves. So same way here we can assume that this is M dash. For example, NFA, simple NFA, it is defined with the help of function M dash Q. Again same, that is nothing but the set of states. Sigma is nothing but the input alphabet. Delta dash, see here, delta dash is nothing but the transition function here. Q0 is nothing but your start state, and F dash is nothing but the final state, right? So NFA without epsilon moves, it can be defined with the help of M dash, that is equal to Q sigma delta dash Q0 F dash. Now here two parameters are being changed here. See here, delta dash and F dash. Here in case of your previous one, in case of ENFA, it is delta, whereas in case of this final states are F. But now they are changing. So delta function, it is changing to delta dash, and F function, it is changing to F dash. So remaining Q remains same in both the cases. See here, point to be noted is that in case of our ENFA as well as your simple NFA, when you are trying to convert this ENFA to NFA, your Q remains same. Means set of states remains same. The sigma set of input alphabet also remains going to same. Start state Q0 is here. Q0 in the new machine, they are remaining same. But which entities are being which are changing here? The changing entities are nothing but your delta. Delta is now converted into delta dash, and F is now converted into the F dash. So see the definition of delta dash here. Delta dash equal to Q into sigma gives you 2 raised to Q. Q into sigma gives you 2 raised to Q here. Getting this point? So state into input gives you the next state. Current state into input alphabet gives you the next state or the new state. So this is the difference between the delta dash and delta here. So you have to map what you have to do here. When you want to change ENFA to NFA, you have to map this delta function with this delta dash function, and ultimately you have to map this F to final, that is F dash, that is nothing but your final state. Getting this point? So see here, so in two NFAs, in given two NFAs, Q, that is nothing but the set of states, input alphabet, and Q0 remains the same. But the difference in the transition function, that is nothing but the delta and delta dash, and the final state, that is delta and F. So hence the transition function for NFA without epsilon moves can be defined for each input A, B as. So see here how the conversion takes place. What do you have to find here? We have to find here delta dash. Delta dash, we have to find here delta dash. So how to find out this delta dash? So delta dash QA, Q is nothing but your state, and A is some input alphabet, equal to delta cap Q in Q comma A, that is nothing but delta cap is nothing but your E closure Q comma A, that is written as E closure of into bracket delta cap Q comma epsilon comma A. So this is the formula. How we are going to get the delta dash Q comma A. That formula we have to use. So remember this particular formula, how to get conversion from delta dash to the delta. So NFA with epsilon moves. So ENFA, we are converting this ENFA to simple NFA. So what we have to get here, we have to get, because Q remains same, epsilon remains, sorry, this yes, this particular sigma remains same and Q0 remains same here. So only the thing is that we have to get, or we have to find out delta dash, and we have to find out the f dash. Delta dash, how to find out this delta dash? The equation or the formula given here for the delta dash calculation, delta dash qa equal to delta cap q comma a. Qa means it is a state, any state, q0, q1, q2, q3, and a is means any input, either it may be a comma b or it may be 0 comma 1, any input you consider here, is equal to f e closure. See the equation or see the formula carefully. E closure into bracket delta transition into bracket delta cap bracket q comma epsilon. So you have to take here epsilon, because why? We are converting ENFA. We are converting this ENFA to NFA. This conversion we require here. So that's why this epsilon transitions we have to consider. So Q, the states, and what is it exactly is the epsilon transition, that state we have to consider. And again we have to take the input A or B or 0 or 1 here, right? So remember this equation carefully so that we can convert. Okay. So let us start with some examples here. So find an NFA without epsilon moves corresponding to NFA with epsilon moves as given in figure. So somewhat the language is different, but what aim is there? So aim is that we have to convert this epsilon NFA with epsilon moves to the NFA without epsilon moves. So ENFA is given here. So this is the diagram for ENFA. Q0 on A input it goes to Q1, Q1 on epsilon input it goes to Q2, and Q2 it has only one transition, B, it is a self transition, right? This is the only thing it is given here. So first step, step number 1, find out E closure of all states as. So first step, we have to find out the epsilon closure of all state, and you know that how to find out the E closure. Already we have discussed E closure of the state, how to find out the E closure of each state. So epsilon closure for each state is nothing but the transition, the state itself, plus how many transition it can reach with the epsilon parameter or the epsilon E closure, that all state we have to consider in the E closure state of that particular state. So E closure of Q0, so there is a no epsilon transition from Q0 state, so that's why we are taking only Q0 state, that is the state itself. Then E closure of Q1, so E closure of Q1, so first include the state itself, that is nothing but the Q1, and epsilon transition Q1 on epsilon goes to Q2, that's why Q2 is included here. So E closure of Q1, we can say Q1, Q2. And the third step is, or the third state is nothing but your E closure of Q2. There is no absolutely epsilon transition on Q2. So that's why the state itself it is included here. That is called as the Q2. So this is the first step while converting ENFA to NFA without epsilon. First, find out the epsilon closure of all states. Find out the epsilon closure of all state, and this is the method. So take first state, E closure of this Q0, that is Q0. E closure of Q1, that is Q1 comma Q2, and E closure of Q2 is equal to Q2. Okay, this is the first step is over. Now go to the second step. Find out the delta dash transitions. Find out the delta dash transitions on each input symbol. On each input symbol. What exactly is the meaning of each input symbol? How many input symbols are there? There are input symbol A and B. So delta dash transition we have to find out. So for Q0A, Q0B, then Q1A, Q1B, then Q2A and Q2B. So all these transitions, so 6 transitions we have to find out. Getting this point? So find out, so delta dash transition, all these delta dash transition for all these 6 transitions, delta dash we have to find out here, delta dash. So delta dash, and what is the formula? Delta dash QA is equal to delta cap Q comma equal to E closure of delta cap Q comma epsilon comma A, right? So this formula we have to use for all 6, 1, 2, 3, 4, 5, 6 states, and we have to find out the delta, this one, we have to find out this one. And once you find out this delta dash QA means what you are finding out? We are finding out the transition in NFA without epsilon moves. These are the transition in NFA without epsilon moves, right? What we are finding out without epsilon. And these are the transitions, these delta transition, these are ENFA transitions. These are the transitions in epsilon NFA. Getting this point or not? So ENFA transitions, we are converting into the transitions for NFA without epsilon moves. Getting my point or not? Right? So epsilon NFA delta transitions, we are converting the transitions for NFA without epsilon, right? So see, step number 2. So take first input and take the first step input. First is A, right? First input is A and the state is Q0. So formula tells us that E closure, see write down the formula for this Q0 and A, E closure of delta cap Q0, take the state epsilon as it is. And what is the input? Input is A, right? Now delta cap Q0 E means what? It is nothing but your E closure of Q0. So you write the value for this delta cap Q0E. This is nothing but your E closure of Q0. All right, remains all other things remain same. E closure of delta into bracket E closure of Q0, comma A is A remains as it is. Right now, what is the E closure of Q0? Already we have find out E closure of Q0. Right. So what exactly the value of Q0 epsilon closure of Q0? It is the Q0 itself. So I can have the E closure delta. So this value is written here Q0 and A as it is. Getting this point or not? We are solving step by step. So first we have written the formula here for Q0A, that is E closure of delta cap Q0 comma E. But what is the meaning of delta cap Q0 comma E? So delta cap. So this is the delta cap is nothing but your E closure. Already we have seen this, right? So delta cap, meaning of delta cap is nothing but your epsilon closure of that particular state. So E closure of Q0 comma E is nothing but your E closure of Q0, and E closure of state Q0 is the state itself. Now, so now this delta Q0A, what is the meaning of delta Q0A? So delta Q0A means what? What exactly the transition from Q0 on state A, right? So we have to see the diagram. So Q0 delta Q0 comma A, where is the transition? So transition go to Q1 state. Getting this one? Transition goes to Q0 on A, go to Q1 state. So I can write here E closure of Q1. Getting this point or not? E closure of Q1. So answer of this particular delta Q0A is nothing but your Q1. I have written here. And now E closure of Q1. What is the E closure of Q1? E closure of Q1 already we have written. That is nothing but your Q1, Q2, right? So see this one, Q1 and Q2, right? So this is nothing but our answer to this particular transition. So this transition delta dash Q0 comma A is equal to Q1, Q2. This is the answer to that particular first transition. This is the solution of the first transition Q1 comma Q2. Means in the resultant NFA, without epsilon, there is a transition from delta, delta dash Q0 on input A. It goes to Q1 state and it goes to Q2 state. Getting this point or not? Right. So like this way, we have to find out all other transitions. So Q0A, we have to find out it. We have to find out Q0 on B. We have to find out Q1 on A, Q1 on B, Q2 on A, Q2 on B. Step by step and same formula. The same equation, same way we have to solve this particular equations, right? So see here, Q0 on B. State remains same. And the only input is different here. That is nothing but B. So E closure of delta cap Q0 epsilon B, right? So what we are finding out here, E closure delta. So the meaning of this delta cap Q0 epsilon is nothing but your E closure of Q0, E closure of Q0. So delta E closure of Q0, sorry, here is nothing but your B, right? So E closure of Q0 is nothing but your Q0 itself. E closure of Q0 is nothing but Q0 itself. Again, we are getting here Q0 and this is nothing but your B as it is. So delta Q0B. So Is there any transition from Q0 on input B? No. When you check the diagram, there is no transition on from state Q0 on input B. So we can write here E closure of phi, and that is nothing but phi, because there is no transition. You want to check it, so just check it on the in the diagram itself. Q0 on A is the only transition. Q0 on B, there is no transition. That is nothing but empty transition, or we can call it as a phi. And E closure of phi itself, it is a phi, right? Okay, so we have got these two things, Q0 comma A, we have got this transition, and Q0 comma B means in resultant NFA without epsilon, these two transitions we have already find out. We have to find out now Q1 on A, Q1 on B, Q2 on A, Q2 on B with the same method, with the same equation, right? So take this transition delta dash Q1 on A. Same way Q1 on A, the equation tells us that E closure of delta cap Q1 comma epsilon A, right? Now E closure, so delta cap Q1 A, Q1 epsilon means what? It is nothing but your epsilon closure of Q1. It is nothing but your epsilon closure of Q1. So what we have to do here, E closure of Q1, what is the answer for you? E closure of Q1? E closure of Q1 is nothing but your delta. So E closure of Q1 value is Q1, Q2. Value of E closure of Q1 is nothing but your Q1 and Q2. So delta Q1, Q2. So how to expand it? How to expand it? See here. E closure of delta. So how to delta Q1A, Q1A union. So this is the symbol of union, delta Q2A, right? So this term we have to expand it in this way. Delta Q1A union transition means delta transition Q2A, because these are the two states. Q1 is one state and Q2 is another state, and we have to check the transition of each state on the input is equal to A. That's why we have expanded it, and we have to take the union. We have to take the union. So like this way, that's why we have put here union symbol. So again, so this is simple one, delta Q1 on A. What is the transition of delta Q1 on A and delta Q2 on A, that we have to write here. So both are phi. So Q1 on A, there is no transition from state Q1 on input A. That's why it is written as a phi. There is also no transition on Q2 on A. That's why it is written as a phi. So E closure of union into union, phi union phi is nothing but your phi. That's why it is nothing but your phi. It is marked here, right? On the same way, Q1 on B. So same way Q1 on B, we can write here E closure delta cap Q1 comma epsilon comma B. So what is the meaning of this? Delta cap Q1 on B, it is nothing but your E closure of Q1. And what is the value of E closure of Q1? It is nothing but your Q1 comma Q2. So it is a delta, right? So again we get the same here, Q1 comma B union delta Q1 comma Q2 comma B, right? And we have to find the transition. Now see the steps here. E closure of delta delta into bracket E closure of Q1 comma B here. So here B. Then again we have to go here E closure delta Q1 comma Q2B, that is equal to E closure of delta Q1B. We expand it Q1 comma B union delta Q2 comma B, right? So what is the output for what is the transition delta Q1 comma B and Q2 comma B transition? So these are the transition. So Q1 on B, there is no transition. That's why it is written as a phi union. But there is a transition from Q2 on B. There is a transition on Q2 on B, and that is nothing but your state Q2. So we can write here E closure of Q2. E closure of Q2. And what is the E closure of Q2? E closure of Q2 is the equal to Q2 itself, right? So here we have got the two answers. First is the phi, and second is nothing but your Q2, right? Okay, so 4 transitions we have find out. Now go to the next one. We'll move to the next one. Q2A, the third state, and with the input A, Q2A E closure of delta cap Q2 comma epsilon comma A, that is equal to E closure of delta. So the meaning of delta cap Q2 epsilon is nothing but your E closure of Q2, and E closure of Q2 is nothing but the Q2 itself. That's why delta Q2 comma A, and delta Q2 comma is nothing but the phi. There is no transition from state Q2 on input A. That's why it is marked as a phi. So the answer is phi. Now take the another input, that is B, and state is Q2 itself. So Q2 on B, E closure of delta cap Q2 comma epsilon comma B, that is equal to E closure of delta E closure Q2 comma A will go to E closure of delta Q2 comma B. E closure of Q2 is nothing but your Q2 itself, and we have to find out delta Q2 B. So is there any transition on delta Q2 B? So that state itself Q2. The answer is, that's why we have to find out the E closure of Q2 is nothing but the Q2 itself. So how many answers we have found out? We have found out the 2 plus 2 plus 2, that is 6 transitions we have found it out. So see here, this is the diagram, this is the transition table, and this is the final NFA. Transition table Q0. So this is the transition table for NFA without epsilon. This is the final table NFA without epsilon. So this is, you know, that this is the Q and this is the sigma AB. Q0 on A, Q1, Q2, which we have find it out. Q0 on B, it is nothing but the phi. Then Q1 on A is the phi. Q1 on B is nothing but the Q2, and Q2 on A go to phi, and Q2 on B is nothing but your Q2. So from this transition table, we have to draw the final NFA. We have to draw the final NFA without epsilon transition, right? So see here, Q0 on A go to Q1, and Q0 on B go to phi, means there is no transition on Q1 on B. That's why there is no transition. Okay, so Q0 on A go to Q1 and Q2. So first transition is on Q1, and Q0 on A go to Q2. These are the two transitions, right? Now Q1 on A is the phi, but Q1 on B go to Q2. So that's why Q1 on B go to Q2, and Q2 on A is the phi, no transition, but Q2 on B go to Q2. So Q2 on B go to Q2. So see here, this diagram you will find here, no epsilon transition is there. All the epsilon transitions are removed, and instead of epsilon transition, we have transition on A, B, or, but there is no epsilon transition here. That is the method how we are converting ENFA to simple NFA without epsilon, right? This is the way, right? So this is the case, this is the way how we are finding out, how we are writing this particular thing. So Q0, so see the previous diagram and see this particular diagram. So in case of previous one, there is one epsilon transition, and that epsilon transition is now completely removed in this particular resultant NFA. This is the method how to draw this particular, find out this particular NFA without epsilon, right? Okay. Now let us go to the next example. Another example we'll see here. Convert the given NFA with epsilon moves to NFA without epsilon moves. See here, there are two epsilon transitions are given in the diagram, that is Q0 epsilon goes to Q1, and Q1 on epsilon transition go to Q2. We have to remove this epsilon transitions, and there are remaining transitions on B, A, B. They are given, right? So what is our first step? First step is to find out the epsilon closure for all the state. So how many states are there? Q0, Q1, Q2. First step is to find out the E closure for all the states. So find out E closure for all the state as E closure of Q0. Yes, Q0, you can have the state itself Q0. Then on epsilon go to Q1, and Q1 also on epsilon go to Q2. That's why E closure of Q0, Q1 and Q2. Remember this point. E closure of Q1, the state itself, and only E closure it goes to Q2. E closure of Q2 is nothing but the Q2 itself, because there is no epsilon transition on Q2 state. So remember this point. So first step is to find out the E closure of all the state. The second step, what is the second step? Second step, find out the delta dash transitions on each input symbol as delta dash QA equal to delta cap Q comma A equal to E closure delta into bracket delta cap Q comma epsilon comma input, right? So how many states are there? So Q0A, we have to find out this, then Q0B, then Q1A, then Q1B, and Q2A and Q2B. So how many total? 2 plus 2 plus 6 transitions we have to find out for our resultant NF, right? So start finding out with the help of this formula. Delta dash q0 comma a, delta dash, remember we are finding out the delta dash transitions, we have to find out the delta dash equal to e closure of delta cap q0 comma epsilon comma a. What is the delta cap q0 a? Is nothing but your e closure of q0, delta e closure of q0. So this value is nothing but your e closure of q0. And what is the value of e closure of q0? E closure of q0 is nothing but your q0, q1, q2. So write down it here, delta q0, q1, q2 comma a as it is. Now you have to bifurcate it, or we have to split it all the transitions. So we will get here e closure of delta q0 comma a union delta q1 comma a union delta q2 comma a. Getting this point? When we split up all the transitions, delta q0 a, delta q1 a, delta q2 a, we have to split up and we have to make their union. We have to make the union here. So delta q1a is nothing but the phi. There is no transition on input a from state q0. That's why phi. Delta q1a is nothing but your state q1 itself. Delta q2a go to q1 itself. So q1 union of q1 is nothing but q1 itself. So e closure of q1. So e closure of q1. What is the e closure of q1? It is nothing but your q1 q2. So this is the answer for this particular delta dash transition. So we got here delta dash q0 comma a is nothing but your q1 q2. Means in our resultant NFA without epsilon, there is a transition q0 state on input a go to q1 and q0 state on input a also go to q2, right? Now take the next input q0 comma b. q0 comma b e closure delta cap q0 comma epsilon comma b, that is equal to e closure of delta e closure of q0, and e closure of q0 is nothing but your q0 q1 q2. So delta q0 q1 q2 comma b, and we have to split it. All the three transitions will be there, q0 q1 q2 states, and input is b. So see here e closure delta q0 comma b union delta q1 comma b union delta q2 comma b, e closure of q0 union. So q0 comma b, so we have to write down the answer q0 comma b. The answer, the next state is q0. q1 comma b, there is a no transition, there is a no state, there is no such transition on q1 on b, so that's why it is a phi. And q2 on b, it goes to q0 states, that's why q0 union phi union q0 we have written here. So the final is e closure of q0. And what is the e closure of q0? E closure of q0 is nothing but your q0 q1 q2, right? So the answer we can have this delta dash q0 comma b, means in our resultant NFA without epsilon moves, there is a transition q0. If b input you give the b input to q0, it will go to q1, sorry, q0, q2, q1 and q2, three states on the same input symbol it will go, right? Okay, so now take the next state, that is q1 comma a. See here q1 comma a, same method we are applying here. Delta cap q1 comma epsilon comma a, that is equal to e closure of delta e closure of q1 comma a, and e closure of q1 is nothing but q1 q2. So again we have to split it here, delta q1 comma a union delta q2 comma a. The delta q1 a transition is q1 itself, and q2 a the again itself. So this transition we have to find it out from the diagram itself. The diagram which is given in the question. So there is a transition q1 a on state q1 itself, q2a it go to q1 itself. If you want to check it, let us check it in the diagram itself, q2a and q1a. See here q2 on a. So see here q2 on a go to q1 itself, and q1 on a go to q1 itself. That's why q2 on a go to q1 and q1 on a to q1. That's why answer is q1. Right? So q1 on a, q1 and q2 on a, it is a q1. So that's why e closure of q1 is nothing but your q1 Q2. E closure of Q1 is nothing but Q1, Q2. Now, meaning is that in the resultant NFA, our Q1 state on input A go to Q1 state itself, means it is a self loop and it will go to Q2 state. This is the significance. Then is the delta dash Q1 comma B is nothing but E closure of delta cap Q1 comma epsilon comma B, that is equal to E closure of delta E closure Q1 comma B, that is equal to E closure of delta Q1 comma Q2. E closure of Q1 is nothing but your Q1 Q2, and now here Q1B and Q2B, these are the two transitions we have to find out here. Delta Q1 comma B union delta Q2 comma B, and the answers are E closure of phi Q1 on B, there is no transition, that's why phi. Q2 on B, yes, there is a state is Q0. E closure of Q0, and what is the E closure of Q0? You know it, that is Q0, Q1, Q2. So this is the answer for this transition Q1 comma B, right? Now let us move to the next transition, that is Q2 comma A and Q2 comma B. Q2 comma A, so E closure of delta cap Q2 comma epsilon comma A, that is equal to E closure of Q2 comma A. E closure of Q2 is nothing but the Q2 itself, that's why delta Q2, and the delta Q2 is nothing but Q1, that's why we have to write here E closure of Q1, and that is nothing but Q1 and Q2. The same way for delta cap Q2 comma B, E closure delta cap Q2 comma epsilon comma B, that is equal to E closure of Q2 comma B, E closure of delta Q2 comma B, E closure of Q0, that is Q2B, the state is Q0, and what is the E closure of Q0? E closure of Q0, Q1, Q2. All right, so all the transitions, all the 6 transitions we have find it out, means Q0, Q1, Q2 on input A and on input B, all the transitions for the resultant NFA without epsilon moves we have already pointed out. Just make it a transition table. So write down the transition table for this, right? And finally the transition diagram. This is the transition diagram or our resultant NFA. So Q0 here, Q0 on A go to Q1, Q2, Q0 on B go to Q0, Q1, Q2, Q1 on A go to Q1, Q2, Q1 on B, Q0, Q1, Q2, Q2 on A, Q1, Q2, and Q2 on B, Q0, Q1, Q2. So from this transition table, this is our final NFA without epsilon moves. See all these transitions we have drawn. Q0 on A go to Q1, Q0 on B go to Q1, then Q1 on A, B go to Q2, right? So in this way, all transitions, all these 1, 2, 3, 4, 5, 6, all these 6 transitions with their inputs we have to mark here, and we have to draw this resultant NFA. Getting this point? See here, there is no epsilon transition, so all the epsilon transition, whatever the epsilon transitions, all E transitions are removed from this resultant diagram, right? It is very simple. There is no, one can say, no difficult part or any critical part is involved. All the things are very simple. Only the thing is that you have to remember this equation. Whatever, how to start with the equation. This equation, just remember this. Then the rest of the things become easier. So we'll see one more example. So convert the given NFA with epsilon moves to NFA without epsilon moves. Now, what the difference you will find here? So here, instead of 2 inputs, there are 3 inputs involved: input 0, input 1, and input 2. So how many possible transitions will be there? So 3 into 3, there will be 9 possible transitions are involved. So we have to find out Q0 on 0, Q0 on 1, Q0 on input 2. Then on the same way, Q1 on 0, Q1 on 1, Q1 on 2, and on the same way, Q2 on 0, Q2 on 1, and Q2 on 2. So total 9 transitions we have to find it out, because input is 0, input is 1, and input is 2, right? And first is to find out the E closure of all the states. So E closure of Q0 is nothing but Q0, Q1, Q2. E closure of Q1 is nothing but Q1, Q2, and E closure of Q2 is Q2 itself, right? The second step, you know it, delta transitions, total 9 delta transitions for the different inputs, 3 inputs. We have to find it out. Delta dash, all delta dash transitions. The way is simple one. Delta dash Q00, E closure, delta cap, Q0 comma epsilon comma 0, that is equal to delta. This is nothing but your E closure of Q0, E closure of Q0. And what is the E closure of Q0? So E closure of Q0 is Q0, Q1, Q2. And this delta Q0, Q1, Q2, we have to split it out. So after splitting, we'll get here E closure of delta Q0, comma 0, union delta Q1, comma 0, union delta Q2, comma 0. Right? And the answer is Q0 on 0, there is a transition and it goes to Q0. Q1 on 0, there is no transition, that's why it is written as a phi. Q2 on 0, no transition, that's why written as a phi, right? So E closure of Q0 is nothing but your Q0, Q1, Q2. So first answer we have got here, that is Q0, Q1, Q2. Now go to the next one, that is Q0 on 1. State same, but the input is different. So Q0 and Q0 epsilon, the E closure of Q0, the same way E closure of delta Q0, Q1, Q2 on 1. Input is 1 here. So in this first one, input is 0 here. Input is, we are taking 0, but in the second case, the input is 1. Input is 1, right? So E closure of delta Q0, comma 1 union Q1, comma 1 union delta Q2, comma 1, that is equal to E closure of. So what is the answer? Q0 on 1. There is no transition, that's why it is marked as a phi. Delta Q1, comma 1 is nothing but your Q1 itself, and Q2 there is no transition, that's why it is marked as a phi. So E closure of Q1, what is the E closure of Q1? Is nothing but your Q1, Q2. So second answer we have got here. Third one is nothing but delta dash Q0 on 2. See here, delta dash Q0 on 2. So because this is the third input set. This is the third input because in this particular NFA, there are 3 inputs are given, 0, 1 and 2. So third input we have to consider for the state, same state Q0. So E closure of Q0 on input 2. E closure delta Q0, Q1, Q2 on input 2. Split it and take their union. So delta Q0 on 2. Where is the transition from Q0, Q1 on 2 and Q2 on 2? The answer is E closure phi union Q2. And what is the E closure of Q2? E closure of Q2 is nothing but the state itself, Q2 itself. All right? Getting this point? The same way for the state Q1, we have to find that out. Q1 on 0, the same way. E closure of delta Q1, Q2 on 0, that is delta Q1 0 union Q2 0. E closure of phi union phi, that is equal to E closure of phi, we'll get here phi. Means there may not be any transition on Q1 on 0. So the final answer we get here phi. The second Q1 on 1. So Q1 on 1 is nothing but what the answer we get here. So Q1 on 1, we get here E closure of Q1, and E closure of Q1 is nothing but Q1 and Q, right? And now the Q1 on input 2, state Q1 input is 2. So E closure of delta cap Q1 epsilon and input is 2. So E closure of Q1 is Q1, Q2. So split it delta Q1 on 2 and delta Q2 on 2. So E closure of phi union Q2, and E closure of Q2 is nothing but your Q2. Okay, so all these 9 transitions, we have find it out. So finally, delta dash Q2 0 is equal to Q0, that is equal to E closure of delta dash Q2 0, Q2 epsilon 0. So E closure of Q2 is equal to Q2. So delta Q2 0 is nothing but phi. So that is delta dash Q2 0 is equal to phi. Now Q2 on 1 is equal to E closure delta cap Q2 epsilon, that is E closure of Q2, and E closure delta Q2 on 1 and Q2 on 1 is nothing but phi. That's why E closure of phi is equal to Q1 and Q2. So Q2 on 1 is equal to Q1 and Q2. Now Q2 on 2 E closure delta cap Q2 epsilon 2, that is nothing but E closure of Q2, and E closure of Q2 is nothing but your Q2. So delta Q2 transition is nothing but your Q2, and E closure of Q2 is nothing but Q2. This way we have find out all the transitions. So Q0, Q1, Q2, and the transitions are 0, 1 and 2 inputs. So we have written the transition table, right? So transition table is written in this way: Q0 on 0, Q0, Q1, Q2, Q0 on 1, Q1, Q2, Q0 on 2, Q2, Q1 on 0 is phi, Q1 on 1 is Q1, Q2, Q1 on 2 is Q2, Q2 on input 0, there is a phi, Q2 on 1, the phi, Q2 on 2 is nothing but your Q2. And from this particular transition table, this is the transition table. From the transition table, we'll draw here transition diagram of final NFA without epsilon. See here, just a minute. So this is the way. This is the final NFA, that is Q0 on 0, Q0 itself, Q0 on 0 go to Q1, Q0 on 1 go to Q1, Q0 on 1 go to Q2, right? So all these transitions we have drawn here in the final NFA. This is your final NFA, right? Okay. Okay, so this particular session, what we have studied, so conversion of NFA with epsilon moves to NFA without epsilon moves. So there is a no any difficulty while converting. Only the thing is that we have to remember the formula, how to find out the delta dash transition. That particular formula, just remember it and just solve it, all the transitions, and find out for each state, each input transition. When you find it out, you will definitely reach to the NFA without epsilon moves, So this is the outcome. So course attainment of the session to construct the finite state machine to solve problems in computing, and these are the different reference book. Okay, so let us stop here. You have to just revise. You have to solve more examples so that you'll get more idea about this particular conversion of NFA with epsilon moves to NFA without epsilon moves. Okay, so let us stop here.